Well, good evening, class. Today's lesson, 2.9, and actually the next lesson, 2.10, are going to be very similar. And what they're going to be is they're going to be a combination of the inequalities that we just did yesterday, together with the solving equation stuff that we did earlier this chapter. Okay, so what we're going to be doing today is we're going to put those two together, so we're going to be solving inequalities. And so 2.9 is basically part one. Just like we did before, we're going to first break down subtraction addition equations that we're going to solve. And then tomorrow night, 2.10, we'll solve inequalities again, but this time we'll do multiplication and division. And there's a few more things to be careful of when we're multiplying and dividing. We'll talk about that tomorrow. So the cool thing about this is that this is essentially going to be a great review of not only inequalities from last night's lesson, but also of the solving that we did earlier in this chapter. Alright, so let's take a look at three examples of inequalities. And so these look kind of like the equations that we had before, but again, all of these are inequalities. So instead of an equal sign, we have an inequality sign. That said, what we do to solve them is still going to be opposites and balance. So the first one, I have m plus 3 is greater than 6, and I want to get m just by itself. So what I'm going to do is the opposite of adding 3 is to subtract 3. And if I do it on the left, I have to do it on the right. Okay, look familiar? I do a bar. Whenever I'm adding, subtracting, I draw one big bar underneath the 2 minus 3's. I always cancel something out on the variable side, and I get m is greater than 6 minus 3, which is 3. Go ahead and graph that like we did last night. So we're going to put 3 right here. It's an open circle because it's strictly greater than, and it's all the m's that are bigger than 3. So we're going to shade to the right, and we're going to put the variable right here. Okay? We'll just switch colors just so they don't run together. The next one, we have 8 plus t, so we have to get rid of that 8. It's a positive 8, so we're going to get rid of we're going to get rid of it by subtracting 8. So subtract 8 from the left, subtract 8 from the right. Notice that I put the minus 8 right underneath the 8, and I lined up over here on the right the 8 and the 15. Again, something will always cancel on the left side, and so we'll be left with t is less than 7. And so this one will look like this on a number line. We're going to start at 7. Again, it's an open circle because it's strictly less than. And this time, because it's less than, we're going to shade to the left. Notice I'm nice and dark, so there's no question which way I shaded. And even though we shaded to the left, remember that little rule, we always put the variable over here on the right. Okay? The last one, let's go ahead and do this one in green. All right. And so on this one, the variable is actually on the right side. That's okay. We're still going to get it by itself. So we're going to subtract 7 from both sides. Now think about the three commandments. Positive 7, negative 7 cancels out. And so on the right side, we're going to get x. The symbol from left to right is actually less than, but it means the x is bigger. And negative 3 and negative 7, if I combine those, what I'm really doing is I'm adding two negatives. So that's going to be negative 10. Now, that is the correct answer, but we always want the variable over on the left side. So what I'm going to do is I'm going to rewrite this, and I'm going to switch the x and the negative 10, and I'm going to keep the sign so that it points towards the negative 10 and it opens up towards the x. Okay, and I want you to look at these two symbols. The first one says it's all that negative 10 is less than or equal to all the x's. So think about numbers that would work for that. Negative 5, 0, all the positive numbers. Okay, the bottom one basically says the same thing. It's all the things that are bigger than or equal to negative 10. Okay, so notice if I have to have the variable on the left, that everything switches. Both things switch sides and the sign actually changes direction. If you think about why this is true, I think it'll make sense, rather than try to memorize it as a rule. So now let's graph this. X is greater than or equal to negative 10. We're going to put negative 10 here. It's going to be a closed circle this time because of the greater than or equal to. And since we are, again, talking... Oh, that looked like a 3. Sorry about that. So since we're talking about things greater than negative 10, we're going to shade to the right. And again, we put the variable over here on the right. Okay? So that's how you solve inequalities. Notice, basically, we're doing the exact same thing we did when we were solving equations. Some of these might be a little bit trickier, might be a word problem. I know this one's a little hard to read. My stylus was not really cooperating. But an airline, suppose it allows up to 65 pounds of luggage on a flight, and you already have one suitcase that weighs 37 pounds. The question, a real-life question, is how heavy could the second bag be? Now, yes, you could probably just go ahead and do a little arithmetic and figure the answer out here. But what I'd like you to do is try to set up an equation a lot like those ones we just saw here. Okay, and in this case, an inequality. All right, so we know that our bag, B, plus the 37 pounds that we already have has to be up to 65 pounds, which means it could be right up to or equal to 65. So that's basically what they're saying. Our 37-pound bag that we already have plus our new bag is going to be less than or equal to 65 pounds. Okay, once you got that, you solve it by subtracting 37 from both sides. Notice I even lined this one up even better than before, so that over here I can actually show my borrowing. So I'm borrowing from the 6 because I can't take 7 away from 5. So make this 15 minus 7, which is 8, and 5 minus 3 is 2. And so the current bag, now this carries down, the inequality sign carries down, so the bag, the second bag, can be less than or equal to 28 pounds. So as long as my bag is no more than 28 pounds, so equal to or less than 28 pounds, I'll stay within the 65-pound luggage rule, and I'll be fine. Okay, almost there. We got one more thing. All of these equations here involve addition, so we solve them by subtracting. So what if we start with subtraction problems? Well, you've guessed it. We're going to solve these by adding. So on the first one, we're subtracting 13 from m, and that's greater than 29. So the opposite of minus 13 is plus 13. And we're going to add it on both sides, draw a line underneath. Something always cancels out on the variable side, and we get m is greater than, and again, I lined it up carefully so I can actually show my carry. M is greater than 42. And on a number line, this will be an open circle on 42, shade to the right, and the variable is m. Okay, the second one, I'm going to add 4 to both sides. Okay, you got the idea now. And so we get v is less than or equal to 11. So this one, we're going to put 11 here. It's going to be a closed circle because it's less than or equal to. And it's less than, so we're going to shade to the left. And the variable is v. So we'll make it look like a v, not a check mark. Well, I don't know. That probably looks like a check mark. The final one, we're going to add 5 to both sides. And for this one, we're going to get t, this cancels out, is greater than or equal to 16. And so again, we're going to start at 16, closed circle because of the equal to, and greater than, so we shade to the right. Okay, so really this should be becoming very standard at this point. They really are pretty simple to graph these inequalities. Just be careful about whether you're talking about a variable that's bigger than a number or smaller than a number. You don't have to memorize left right. It should be pretty obvious. Okay, to wrap things up, we're going to end with a little picture of an owl. We will be practicing these extensively in class tomorrow. So tomorrow is going to be one of those days where we're going to have a lot of problems to do in classwork. So just come in ready to work. You'll copy the problem down. You'll show all your work. You'll actually show the adding and subtracting on both sides. And we'll really just get really good at this. And so it's going to help us practice our inequalities, and it's going to help us practice solving, it's going to help us practice solving, whether it's an equation or an inequality. So I will see you in class tomorrow. Take care.